Hello, everyone. Today we're going to talk about exponent rules. Let's start with our first rule. So our first rule of exponents we're going to talk about is if we have two things with the same base. So let's say we have base A and they have exponents x and y. So we're multiplying these here. So a to the x times a to the y. This is the same thing as a to the x plus y. So we multiply two things with the same base, we're allowed to add those exponents. Similarly, if we divide two things, so if I have a to the x over a to the y, I'm allowed to subtract those exponents. And it's important here, this only works if we have the same base. If they don't have the same base, I'm not allowed to do this. So a can be anything. So if we throw some numbers in there, 2 to the third times 2 to the fourth, it's the same thing as 2 to the 3 plus 4. So 2 to the seventh. Or if I have 2 to the fourth divided by 2 to the third, that would be 2 to the 4 minus 3, which would be 2 to the first, which is 2. Okay. So another rule that we'll see a lot is a negative exponent. So let's say we have a to the negative x power. So whenever we have a negative exponent, we normally want to get rid of it. So what we're able to do is write it as the denominator. So this is the same thing as 1 over a to the x. So if I have 2 to the negative third, this is the same thing as 1 over 2 to the third, or 1/8. Let's say I have a power raised to a power. So let's say I have a to the x raised to the y power. A power raised to a power, we're allowed to multiply those powers. So 2 squared to the third is the same thing as 2 to the 2 times 3, which would be 2 to the sixth. So power to a power, we multiply. If I have anything to the 0 power, that is 1. So we don't need an example of that one, but anything to the 0 is 1. I am also allowed to distribute powers. If I have, let's say, a times b to the x, this is the same thing as a to the x, b to the x. And we've probably seen this one before. Let's say I have 2x raised to the third. This is the same thing as 2 to the third times x to the third. So I have to do the third power to both of those things. And the same rule applies if I'm dividing. If I have a divided by b to the x, this is the same thing as a to the x divided by b to the x. So if I have 2/3 squared, it's the same thing as 2 squared over 3 squared. We have a couple more. Let me erase a little bit for that. All right. So something we'll see a lot in this class and want to switch between the two to make taking derivatives, which we'll talk more about a little bit easier, is if we have a fractional power. So if I have something like a to the 1 over n, this is the same thing as the nth root of a. So saying 3 to the 1/2, this is the same thing. So sorry, this is rule number 8. If I have 3 to the 1/2, this is the same thing as the square root of 3. So when we have 2 as our root, we don't write the 2. But if we had like 3 to the 1/3, that's when we write the cubed root. So square root, really you could write that little 2 there, but we don't typically do that notation-wise, it's assumed it's the square root. So 1/2 power is square root. We are going to use this fact here a lot. Very similarly, if I have a fractional power again, but it's a to the m divided by n instead of a 1 as our numerator, this is the same thing as the nth root of a to the m, or the nth root of a to the m power. So it doesn't matter which you do first. Normally it's easier to take the root and then raise it to a power. So if I have something like 4 to the 2/3, this is the same thing as, let's say, doesn't matter which way we do this one, the cubed root of 4 squared. The denominator is our root, and the numerator is our normal exponent. So those are some rules. Let's look at a few examples with these rules. So let's say we have something like this. 3 times xy squared. If we want to simplify this, what I'm going to do is I'm going to square everything. So I do 3 squared, x squared, y squared. So that's one example. Let's say I have something like 4x over y to the negative 2. So here I need to use two rules now. So I have this negative exponent, and I earlier showed the negative exponent is the same thing as 1 over. Saying 1 over a fraction, what we're really doing is flipping the fraction. So whenever I have a negative exponent, to get rid of it, I can flip this fraction and make it y divided by 4x squared. So that's the same thing. Now that we have just a squared, I can go ahead and square everything. So I have y squared, 4 squared, and x squared. So that would be fully simplified. Let's look at one more. Let's say we have 4x to the 7th, y to the negative 3rd, divided by 2x to the 3rd, y to the negative 2 squared. Okay. So with these bigger problems like this, I can do this in a bunch of different orders. It's really just preference of how you want to do it. When I have something like this, I could either square everything and then solve, then the numbers get a little bigger, or I could simplify the parentheses and then just square everything at the end. It really doesn't matter the order. I'm going to do the parentheses first. So since we have all the same variables and some coefficients, I can go term by term and solve them. So this is the same thing as 4 divided by 2. 4 divided by 2 is 2. X to the 7th divided by x to the 3rd. Remember, when we divide, we're allowed to subtract. So this is x to the 7 minus 3. And then same thing with y. Minus 3 minus negative 2 would become plus 2. Right? Because a minus a negative number is the same thing as plus. Then we have this whole thing squared. So I have 2x to the 4th, y to the negative 1, and then this whole thing is squared. So in that step, I just did the 7 minus 3 and minus 3 plus 2. Let's square everything. So I have 4x. If I do a power to a power, we multiply. So that's 8, and then y to the negative 2. And then I don't like to have negative exponents, so my last step here, I'd have 4x to the 8th divided by y squared. So if you got to 4x to the 8th, divided by y squared a different way. That's more than okay, as long as you get to that final simplified answer. We only always want one variable, so I should only see x appear once. I should only see y appear once. I shouldn't have an x in the numerator and denominator. And then I never want to have negative exponents as well. All right, that's going to be it for exponent rules today. Have a great day, everyone.